Imagine a universe with no stars, no sunlight, no warmth, no new beginnings. Just a cold, dying cosmos where the stars have faded out, one by one. Silence. In this final, empty darkness, there is only one thing left that truly matters: gravity. Long after the last star burns out, long after the galaxies themselves fade into memory, there may still be planets. Not orbiting stars, but orbiting the graves of stars, black holes. These are not worlds of life as we know it. They are the final planets. And tonight, we are going to fall into their sky. We know planets form around stars. It's a familiar story of heat, light, and vast disks of gas and dust. But black holes? They are the complete opposite. They are cold, invisible, silent endpoints. And yet, the fundamental laws of physics not only allow planets to orbit them, but practically guarantee their existence. Some may already be out there, ghost worlds in the dark. Others are yet to be born, in the unimaginably distant future, in a universe growing colder with every passing second. These may very well be the last planets that will ever exist. This is a realistic simulation, created using the software Space Engine, guided by the real principles of orbital mechanics, general relativity, and cosmology. So let's begin our journey at the place where light itself almost ends. Can planets really orbit black holes? The answer is a simple yes. From a distance, a black hole's gravity is no different from a star's. If our sun were to be suddenly replaced by a black hole of the exact same mass, something surprising would happen: nothing. Well, not quite nothing. Day and night would vanish, plunging Earth into eternal darkness. But our orbit, the path we trace through space, would remain completely unchanged. The gravitational pull would be identical. This means planets can survive the death of their parent star. And in some remarkable cases, they can even be born from that death. Think about what happens when a truly massive star dies. It collapses under its own immense gravity and explodes in a supernova. But not everything is lost into the resulting black hole. A significant amount of leftover material, a sort of stellar ash, can get caught in orbit, forming a swirling disk around the newly born singularity. Over millions of years, that disk can cool down. The particles within it can start to clump together, condense, and grow. Planets can literally form from the ashes of a dead star. This isn't just a theory. Astronomers have already discovered planet-mass objects orbiting neutron stars, the other kind of stellar corpse. So, planets orbiting black holes aren't fantasy. In the grand timescale of the cosmos, they are inevitable. Let's approach one of these systems. From a distance, it just looks wrong. There's no glowing star at the center, no beacon of light. There is only a darkness that bends and warps the universe around it. The stars of the distant galaxy behind the black hole are stretched and twisted into glowing rings of light, an effect called gravitational lensing. The planet itself follows a silent, perfect, and seemingly endless orbit around this invisible anchor. This is gravity in its purest form, stripped of all warmth and light. Now for the truly mind-bending part. What is the sky like from the surface of one of these worlds? Stand on the frozen ground and look up. There is no Sunday. The sky is an eternal, unchanging night. But it is not empty. The black hole acts as a cosmic lens, distorting the entire celestial sphere. The glorious band of the Milky Way is bent into a shimmering halo that encircles the darkness. Stars appear duplicated, with ghostly copies shimmering beside the originals. Some stars might even appear to move backward in the sky as their light follows a curved path around the black hole. Time itself feels different here. It's not stopped, but it feels stretched. This sky never changes. There is no dawn. There is no sunset. There is only the silent, perpetual rotation of a world under a black sky. But wait. Without a star, how could a planet have any warmth at all? It would be impossibly cold, wouldn't it? There are three possibilities for heat without light. First, internal heat. Just like Earth, a planet can be warmed from within by the decay of radioactive elements in its core. Second, tidal heating. The immense gravity of the black hole would constantly squeeze and stretch the planet, generating friction and heat deep inside its crust. And third, if the black hole is actively feeding on stray gas and dust, it can form an accretion disk. This disk would glow fiercely, not in visible light, but in high-energy X-rays. If that's happening, the sky would have a faint, lethal glow. Eerie auroras would ripple across the atmosphere. This is not a world made for life. It is a world of survival, existing at the very edge of physics. But orbits don't last forever. Nothing does. Over eons, gravitational interactions with other objects and the emission of gravitational waves slowly drain the planet's orbital energy. The planet begins an incredibly slow, graceful spiral inward. From the surface, the black hole in the sky would appear to grow. It's still invisible, a perfect sphere of nothing, but its influence expands. The stars behind it warp more and more violently. Time dilation becomes extreme. A single year passing on this planet might be equivalent to 1,000 years, or 1,000,000, for the rest of the universe. From this world, you would be watching the cosmos age and die in fast forward. As the planet nears its final destination, the black hole comes to dominate the sky. It's not an object you see, but an absence you feel. It is a hole punched directly into the fabric of reality itself. The entire galaxy wraps around it, a breathtaking cosmic crown of light distorted beyond recognition. This is the last sky that any planet, anywhere in the universe, will ever see. Eventually, the planet crosses a critical boundary, the innermost stable orbit. There is no grand explosion, no final dramatic moment. There is just acceleration. The planet begins to stretch, pulled apart by the insane difference in gravity between its near side and its far side. It fractures. The tidal forces become insurmountable, tearing the world apart, atom by atom. Its matter is shredded into a thin stream, which joins the accretion disk for a final, fleeting blaze of glory. And then, just like that, it disappears across the event horizon, gone from the universe forever. Long, long after the last star dies, in the cold and the dark, black holes will remain. And for a time, for perhaps trillions of years, planets may continue to orbit them. Dark, cold, silent. These are not worlds of hope or new beginnings. They are monuments. They are the final proof that gravity outlives light, and that even at the absolute end of everything, structure can still exist. The universe doesn't end in a blaze of fire. It ends in quiet, stable orbits, around nothing. It reminds us that when all the stars are gone, gravity remains. Thank you for watching.